Okay, this first problem up here, number 1, with his 1 over x plus 1 over 2x equals 1 over 6. The strategy with these rational equations is find the LCD, find the lowest common denominator of all the denominators, and multiply every term by that. So this first term only has an x in it, the next one has a 2x, and the last one has a 6. And of course 6 is made up of 2 and 3. So we've got to find a denominator that has all three of these things in common. So it needs to have a 2, because this one and this one have 2's. It needs to have a 3, because this one has a 3. And it needs to have an x, because this one and this one have an x. So the LCD is 6x. So if we just take 6x and multiply it by all three terms, just kind of imagine a 6x coming over and landing on top of that. You'd have 6x over x, and bring it over to here, and have 6x over 2x, and then take it over to here, and you'd have 6x over 6. And now you can reduce each fraction, and there won't be any denominators. In other words, we've guaranteed to kill all the denominators. This x kills that x, this x kills this, that 6 kills this, and of course in the middle fraction 6 over 2 is equal to 3. So we get 6 plus 3 equals x. So x equals 9. So I'm not quite sure. Looks like that's what you had. Not quite sure where it was marked wrong. Let's see, number 8 here. I don't know if that's marked wrong or what. Looks like there's a question mark on it, so let's take a look at that one. You've got 2 over x minus 2 plus 5 over x plus 2, and then you've got an x squared plus 6, and the key thing here is that this x squared minus 4 to the negative 1, that means it's in the denominator like that. So having a kind of like having a first exponent down there. Now we can see that this denominator, this x squared minus 4, is really x plus 2 and x minus 2. And of course we got x squared plus 6 up in the top. So let's take each term, if we kind of just forget about this now that we have it factored there, and we find the LCD of all the three terms, we've got an x minus 2, an x plus 2, and an x plus 2, and an x minus 2. So that is going to be our common denominator. So we're going to multiply each fraction by x plus 2 and x minus 2. And so when we take this quantity and we bring it over to here, the x minus 2's are going to kill each other, so we're going to have a 2 and an x plus 2. And when we take it over to here, the x plus 2's are going to kill each other, so we're going to have a 5 and an x minus 2. And then when we take it here, it's going to, all that whole denominator is going to get killed, and we're going to get x squared plus 6. So we're going to get 2x plus 4 plus 5x minus 10 is equal to x squared plus 6. And as soon as you have it so that there's no denominators anymore, all we have to do is get one side equal to 0, and we'll probably be able to factor it. So let's get our like terms here. We've got 7x minus 6 equals x squared plus 6. So I'm going to add 6 and subtract 7x from both sides. So I'm going to add 6 and subtract 7x. We'll have 0 equals x squared minus 7x plus 12. And sure enough, that's going to factor to x minus 4, x minus 3. And so we get two solutions, x equals 4, which makes this factor equal to 0, and x equals 3, which makes that factor equal to 0. So there's your two solutions. Now, the trick with these is you want to take those solutions and put them back in the original equations and make sure that they don't give you a 0 in a denominator. And I think they would not. I think you'd be okay with that. So I think both of those are valid solutions. it looks like on this page you're just trying to get common denominators and then add the numerators, or subtract, depending on what it is. So for example, this one's got subtraction in it. Your LCD, this is correct, is x squared x minus 2, because there's an x, there's two factors of x here, and there's an x minus 2. So we're going to need two factors of x and an x minus 2, which is what you have there. So, not sure. Oh, I think what you did here is you just put the x, you just made the denominator x squared x minus 2, but you didn't do anything to the numerator. When you're getting a common denominator, like if you have 4/3 plus 1/5, let's say, back in the day, the common denominator is going to be 15 because you need a 3 and a 5. Well, you can't just put a 5 here and put a 3 there because you've just totally changed the addition. You're now doing 4/15 plus 1/15, which is not what the problem originally asked. You have to, the only thing you're allowed to do to a number without changing is multiply it by 1. So if you multiply by 5/5 on this side, then you're going to get 20/15. And if you multiply this by 3/3, again, that's 1 that you're multiplying it by, so you get 3/15. So you'd have 23/15 because you've got 20 plus 3/15. So in something like, I don't know, we'll go through and do this guy here. I can't tell what number that is, 8 maybe. You've got 3/x plus 2/x minus 2 and minus 2/x squared. And you said your common denominator is x squared, x minus 2. So I write my fractions spread out like this so that I can put in the additional information that each fraction needs to get that common denominator. So let's keep an eye on this common denominator. And if we want every denominator to look like that, we're going to have to give this guy another x and an x minus 2. But if we do it to the denominator, we have to do it to the numerator also. So we're going to give it an x and an x minus 2. For this middle one, it already has the x minus 2, so he just needs an x squared, but we have to put it in the top also. And then the last fraction has the x squared, but it doesn't have the x minus 2. So we give an x minus 2 in the bottom and the top. Now we can write our common denominator, which is going to be x squared and x minus 2. But our numerator, first of all, this first one, is going to be 3x squared minus 6x. Take the 3x and multiply it by x, and the 3x and multiply it by the negative 2. Then we take this guy, which is just 2x squared. And then lastly, we have to think about this negative 2 multiplying by that x to get us minus 2x, and a negative 2 multiplying by that negative 2, and we get a positive 4. So we can just clean up our like terms in the numerator, and it looks like we're going to get 5x squared. Let's see, we've got minus 6x and minus 2x, which would be minus 8x and plus a 4, all over x squared, x minus 2. Now, you always have to watch out. This numerator looks like it might factor, and I think it will. Let's try and see what we get if we do 5x and an x, and let's see, maybe a 2 and a 2, and we do a minus and a plus. Yeah, that's sure enough, that's what's going to happen. And look what happened. The numerator factors to 5x plus 2 and x minus 2, and the denominator has an x minus 2 in it. So we can cancel that with that. And there's our final answer, 5x plus 2 over x squared. That's a tricky one. We could do one more here. Maybe, well, let's go down here and do 11. That looks straightforward enough. There's a 2 over a 1 and an x over an x squared minus 2. So, you know, our common denominator is just going to be x squared minus 2. If we had an x squared minus 2 here, then they'd be the same. So I'm going to go ahead and put x squared minus 2 there, but I have to do it to the numerator also. So our new, well, not our new, our common denominator is x squared minus 2. And in the numerator on the left side over here, we're going to get 2x squared minus 4. And then we're adding that to x. So we get 2x squared, just rearranging our terms, plus x minus 4 over x squared minus 2. And you might say, well, how do I know if this is going to factor like this last problem did? Well, the way to tell if something's going to factor is you multiply the front term and the last term. And if we did that, we multiply to get negative 8. And then you look at the middle term, which has a positive 1 there, positive 1x. And you ask yourself, are there any two numbers that multiply to get this that add to get that? And the only numbers that we have to multiply to get 8 are 8 and 1 and 2 and 4. And there's no possible combinations of 2 and 4 or 8 and 1 when you multiply them together with the positive and negative versions of each other that you're ever going to add up to get 1. So that's not going to factor, and that's as far as it goes. So hopefully you have a sense of this stuff. It's all about finding the common denominator carefully and then making sure if you make an alteration to one fraction, you do it to both the top and the bottom.